Hello friends, today we are going to see a topic named Intercept of a line on our coordinate axis. Intercept of a line. So we'll see first what intercepts is all about. Suppose, let's say we have coordinate axes as x-axis and y-axis. If a line intersects our coordinate axis at 2 points A, let me mark point A and point B, where point A is the intersection point of our line with x-axis. So let's say L is the line which intersect our x-axis, which is this one, at point A, and y-axis at point B. We're taking O as the origin of the intersection of the coordinate axis. We will say that OA is the x-intercept, and OB is equal to y-intercept, which our line L makes with x-axis and y-axis respectively. Now the sign of x-intercept and y-intercept varies in such a way that if the line intersects the x-axis at the positive x-axis at point A, then the sign is positive. But if the line intersect the negative x-axis at some point, then it will make negative x-intercept. Similarly, if a line intersect the positive y-axis at some point, it will make the positive y-axis, positive y-intercept. And similarly, if the line intersect at negative x-axis at some point, then it makes negative y-intercept. So here we cover up the intercept definition. Now we shall see the equation of line which are parallel to the our coordinate axis. So I'll put in this way: equation of line parallel to coordinate axis. Suppose a horizontal line is at a unit distance from x-axis. So I'll first draw our axis. This is our x-axis and this is our y-axis. This is positive direction of x-axis. This is our intersection point of coordinate axis, which is known as origin, and this is our negative direction of x-axis. Upwards is positive direction of y-axis and downwards is negative direction of y-axis. So if a horizontal line is at a unit distance from x-axis, that means, let me draw a line parallel to x-axis. Similarly, I can draw a line which is of unit distance parallel to x-axis over here. So these are the lines, let's say L1 and L2. L1 and L2 are parallel to x-axis and at a unit distance, that is 1 unit distance. Similarly, L2 is also at 1 unit distance. Then the y coordinate of every point lying on L1 and L2 will remain same, and for L1 the y coordinates value, let's say denoted by small y, would always be 1. Similarly, the y coordinates value for L2, let's say denoted by y dash, will always be -1. Similarly, if I take this L1 and L2 line, instead of unit distance, I'll put this distance as some a, then the y coordinate of L1, that is y1, will always be a, and y coordinate of L2 will always be -a. Hence, I can say that the equation of line y equal to a or y equal to -a will always be a parallel line to the x-axis. Now the sign for a depends how the line is positioned on the coordinate plane. If the line is at a distance of a unit above our x-axis, then we shall get y equal to a, and if the line is parallel to x-axis and below it at a unit distance a, then we shall get the equation of the line L2 as y equal to -a. Similarly, suppose we have a line. Let me draw the coordinate axis. This is our y-axis and this is our x-axis. Suppose we had a line which is parallel to our y-axis. These are the two lines parallel to y-axis. I'll name them as M1 and M2. And these lines are at a distance b from y-axis. Each of this line are at a b unit distance from y-axis. Then the x coordinate for line M1 and M2, that is x1 and x2, will be plus b and minus b. We are taking x coordinate as plus b for line M1 because all the coordinates on this line lies to the right hand side of our y-axis, hence all the x coordinate becomes positive. Similarly for M2, all the x coordinate will have a negative sign. The reason is all the coordinates of x-axis on M2 lies towards the left hand side of the y-axis, hence we shall get the negative sign for the line M2 and its coordinate, x coordinate. Hence we can say that the equation of a vertical line at a distance b from the y-axis is either x equal to b or x equal to minus b. So from here on we'll move on to our next topic, which is different forms of equation of our straight line. Let me write it. Different forms of equation of our straight line. The first form, and it is among the most prominent form of all the forms, is slope intercept form. Slope intercept form of the line. Slope intercept form. I'll define the equation of the line first in the slope intercept form. The equation of the line with slope m and making a y-intercept c is equal to mx plus c. This is the slope intercept form of our straight line, where y is equal to mx plus c, and m is the slope of the line and c is the y-intercept of the line. Now we shall see how we had derived the straight line in these terms, slope and intercept terms. Let me first draw a coordinate axis. Let's say this is a x-axis and this is a y-axis. Let's say a line intersect our coordinate axis at points P and Q and makes an angle theta with the positive x direction. Over here I can say that my OQ is the y-intercept which our line makes with the y-axis, and I'll name our y-intercept as C. So this distance OQ becomes C. Now let's say this line passes through one point R with coordinates x and y. Sure. Now first I'll draw a perpendicular on our line on our x-axis, and then I'll draw a perpendicular from point Q on the perpendicular which I had drawn from R to x-axis. I'll name the point of intersection of the perpendicular drawn from R to x-axis as S and from Q to RS as T. So I'll get 90 degree over here and 90 degree over here. Now I can say that since RS is perpendicular to x-axis and QT is perpendicular to RS, so QT becomes parallel to our x-axis, and hence the line L which makes a theta angle with our x-axis also make the same angle over here as theta, since QT is parallel to x-axis, and hence the line acts as a transversal for these two parallel lines. So I can write theta, which the line makes with our x-axis, is the same angle of inclination over here, that's theta. Now in triangle RQT, I can say that tan theta is equal to RT upon QT. Now my OS, I'll name this as equation number 1. I can say that OS, which represents the distance from y-axis of the point R till S. Hence, it is the x coordinate. OS is the x coordinate of point R. So I can write OS equal to x, which through which I can say that QT is also equal to x, since we have dropped a perpendicular from here. So QT, the length of QT becomes the length of OS. So QT also becomes x. So I'll put QT as x. Now I see that this distance from x-axis RS is represented by the y coordinate of point R. Hence the whole RS becomes y. But I know that my RS is equal to RT plus ST. Now since ST is equal to QO, I can write RT plus OQ. Hence our RS was Y, RT plus OQ. OQ is the y-intercept, that is equal to C. Hence I can say that RT is equal to Y minus C. Now I'll substitute our values of QT and RT in our equation number 1. So we shall get tan theta is equal to Y minus C upon X. Tan theta, RT is Y minus C and QT is X. So tan theta is equal to Y minus C upon X. But I also known as that theta is the angle of inclination which the line makes with the positive direction of x-axis. Hence, tan theta represents the slope of my line. Let's say I took the slope of my line as m. Then m is equal to tan theta. I'll put this value in above equation over here. So I'll get m is equal to y minus c upon x. I'll cross multiply it. I'll get mx is equal to y minus c, which implies that y is equal to mx plus c. So this is the equation of our line in slope-intercept form, where m is the slope and c is the y-intercept. From this form, we'll move on to another form, the second form of the line through which we can depict it, that is point-slope form. Point-slope form of the equation. Point-slope form says that the equation of the line which passes through a point x1 y1 passes through a point x1 y1 and has the slope as m is y minus y1 equal to m into x minus x1. This is the equation in point slope form of a straight line. Now we shall see how we have derived this formula. Let's say we have 2 points q of x1 y1 and p of x y through which our line pass. Then the slope of the line, which over here we have taken as m, is equal to y minus y1 upon x minus x1. As per our formula of slope, we know that if the line passes through 2 points having coordinate x1 and x2, x1 y1 and x2 y2, we have slope is equal to y2 minus y1 upon x2 minus x1. The same formula I am going to apply over here, where the coordinates of 2 points on our line are q of x1 y1 and p of xy. I'll substitute y in place of y2 and x in place of x2, y1 and x1 as it is. So I'll get slope of the line is equal to y minus y1 upon x minus x1. I'll cross multiply it and I'll get a required form, which is y minus y1 is equal to m into x minus x. So this is the required form of our line which was seeking. Now this equation of the line consists of the coordinates of a point x1 and y1, and hence we call it as point slope form, where point represent the coordinates of the point through which the line passes and slope, which is m, represent the slope of the line. Hence it is known as point slope form. On the basis of point slope form, we had one more criteria or one more form by which we can represent our equation of the line. That is 2-point slope of the line. 2-point form of a line. As we had seen our point slope form, we took two coordinates P and Q. On the similar way, over here also we'll take only 2 points through which the line passes irrespective of the value of its slope. So let's say a line passes through point A of x1, y1 and B of x2, y2. Then the slope of the line which passes through these two coordinates is m is equal to y2 minus y1 upon x2 minus x1. Now I'll substitute the value of this m equal to y2 minus y1 upon x2 minus x1 in our early equation of point slope form, where we had y minus y1 equal to m into x minus x1. So instead of m, now I will write the coordinates through which the line passes. So our equation of the line becomes y minus y1 is equal to y2 minus y1 upon x2 minus x1 of x2 minus, beg your pardon, it's x minus x. So this is the equation of the line which passes through 2 points x1 y1 and x2 y2.